Okay, on part D, at t equals 1 is the speed of the particle increasing or decreasing. Well, here's how you decide. If velocity and acceleration have the exact same sign, okay, if they're both negative, then that thing is being pushed to the left, and therefore is the speed is increasing. If they have opposite signs, say one's positive, one's negative, then they're fighting against each other and slowing the particle down. If they're both positive, then it's pushing off to the right. Okay, so we need to find out. So at t equals 1, we'll just substitute in. So v of 1, and really I just care if it's positive or negative, but we'll find the actual value. So v of 1 is going to be 3 minus 9 minus 12. Okay, which is most certainly negative. All right, so we got what, negative 18? All right, and then so it'd be negative 18. We don't know what the units are, so but that would be distance. It's velocity, so distance per unit of time, and then acceleration at 1. Okay, is going to be 6 minus 9, which is also negative. All right, so that means it's going to the left and being pushed to the left, going to the left, pushed to the left. So for that reason, this the speed of the particle is increasing. All right, and your justification would be, all right, since the velocity and acceleration of the particle are both negative at t equals 1. Or you could say they both have the same sign, whatever. Since those are both negative, both have the same sign, the particle is speeding up. Or the speed of the particle is increasing. Or you could say. And either way, same thing. Those are saying the exact same thing. All right, and then it says, what is the particle's acceleration at t equals 1/4? Okay, explain the meaning of your answer in terms of the particle's velocity. All right, how would the units be explained in context to the particle? Okay, cool. So, and again, I don't think we were told any units on this thing at all. Okay, so we'll just act like we know what they are, I guess. All right, so the acceleration then on this thing, here we go. Let's go here. Blue is fine. All right, so the acceleration at 1/4 and again, we don't know what unit of measure that is. I mean, it could be seconds, could be hours, could be who knows. All right, but that's going to be 6 times 1/4. It looks terrible. Minus 9. All right, so 6/4 is 1.5. So 1.5 minus 9 is going to be negative 7.5. Okay, and again, we don't know what the units are, but what this means is that the velocity is changing, is decreasing. We'll type this out. What this means is the velocity, and that's what it's asking us to talk about, of the particle is decreasing at a rate of 7.5, whatever the units are, units of length or distance for each unit of time. Okay, so that means that's how the velocity is changing. Okay, because it did ask us to talk about it in terms of velocity, not the position. Because if it was position, you would say, like, if it was feet in seconds, you would say feet per second squared. All right, but then what we just said though is the velocity of the particle is decreasing at a rate of 7.5 I don't even feet per second. All right, whatever that is. So that I think that takes care of that one.